Okay, well, welcome everyone to our live event. We've had a little bit of a technical issue this morning, but we'll see how we go. I've got Shay Meta. Is it Meta or Meet, Shay?
Mete.
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 So he's on the line. We've jimmied up a presentation. We'll see how we go. So welcome, Shay. Thank you for joining us. Yeah, look, Shay's going to be presenting to us this morning some of the changes to. Whoop. We've lost him there. There he is.
Oh, I'm just sharing the screen.
No,
so
do you want to just share your video, Shay, and I'll be able to talk to you? So what Shay's going to go through is the FPAA 101D and the 101H systems that have been produced for compliance with the NCC, the latest one that's been issued in 2019 as of May, and so these are for buildings that are over 4 stories up to 25 meters. So let me introduce Shay. Shay's been with the FPAA, the Fire Protection Association of Australia, for a number of years now. We've worked together on standards committees. He's been quite influential on those standards committees, developing training programs and so on. He's also been recently involved in building a Centre for Excellence in Sydney with the FPAA preparing what would it be, a training centre for sprinkler fitters, fire technicians and so on. So let me ask you, Shay, what's your background? Where have you sort of come from?
Yeah, I'm actually a sprinkler fitter, and I've been a fitter for 25 years or more. But I've also done some training, as in I was training the apprenticeship at RMIT down here in Melbourne, so teaching the trade for a number of years, but heavily involved in routine service testing and maintenance of sprinkler systems, and run my own business doing that sort of stuff as well. So that's my background, and been at FPA Australia now for I think 3 years full time. Cool.
So what are you going to talk to us? I sort of said you're going to be talking about the 101D and H systems.
Yep.
What in particular about this type of system excites you? What gets you going with this?
Good question. This solves a big problem that I feel we've had in the fire industry for a long time. Clearly, probably most people on this call, I would imagine, would be heavily involved in the commercial occupancies and aspects of the business, and we all do that. And probably almost everyone on this call, I would assume, but this now swings the direction to something towards the residential and even domestic aspects, which I feel is well overdue. In terms of sprinkler protection, as you know, Doug, sprinklers have been available for residential and domestic situations for a long time, but we haven't really cracked into that to the point where we're having a major take-up of those systems. So that's what excites me. This is what I see as step one in a longer game, which is ultimately Class 1A homes, where we can get sprinkler protection in all those homes, because of course that's where the large number of fatalities are.
Yeah, okay. So future heading towards housing, not just sort of high rise or medium rise, but into houses. I'm very excited that in a few weeks time we will actually have the Assistant Commissioner of the Fire Brigade here in New South Wales talking about that kind of future later on, about the Home Fire Sprinkler Coalition and so on. So that, look out for that in a few weeks. We'll make a few more announcements and so on about that as times come. So some of the hurdles you've had, what's been some of the issues you've had with getting these systems into place?
Yeah, well, surprisingly, I think it goes back to the first point, whereby when you do something like this and make what has turned out to be a pretty significant change in the way that we build these systems, unfortunately, you get, and I say unfortunately, but I guess it's to be expected, you get the standard industry that's been using the standard systems, the 2018 systems, and they say, hang on, you're doing something that's different here and it's not equivalent to these standard 2018 systems. You know, yours is different in all of these ways. So, you know, basically prove that these systems are going to be safe. And I guess that's probably been one of the biggest hurdles, really. It's just programming the minds of some of the people in the industries and the stakeholders that are used to a traditional method, and now we're potentially challenging that with a new system type. So that is a challenge, and probably the only other challenge is the huge amount of effort and rigour that's involved in getting such a big change like this over the line with the Australian Building Codes Board, who are fantastic in the process in supporting, mind you, but it is still an extremely rigorous process. So we went through that process and ticked all the boxes, got it through, but certainly they're probably two of the biggest challenges, I'd say.
Yeah, so a big job there. Dealing politically as well as getting the technical side right. It must have been quite difficult. Yeah, so well done.
Correct.
I've talked about further development, so without ado, I'll pass over to you, Shay. I'll sort of drop out. Let me just see if I can play with this screen. So my apologies again to people that are dialing in. We had a few issues here, so we'll see how we go. We've got Zoom inside of Zoom. It's almost like the Matrix or Inception here. So we'll see how we go. So I'll hand over to you, Shay, and off we go. Thanks for that, Shay.
Thanks, Doug. So yeah, before I get started, I just would like to thank Doug and Greg in particular for being really supportive all the way through this process, and also to Johnson Controls who've helped along the way. And I'll talk a little bit more about that help and how, in fact, all of the sprinkler manufacturers have been terrific in assisting through the process. So thanks, guys. I assume you can see the screen. You can see the two specifications there, Doug.
Yes, all good there, Shay.
Yep, great. Okay, so that's what we're here to talk about, the two new residential sprinkler systems that have been introduced into the building code since May 1, 2019. So we'll just talk briefly about how we arrived at where we are now and the reasons we got there. And there are three key drivers for this change. One was the social issues, being the affordability of homes, and obviously the population rise means that, well, I'll talk to those points. The other is the actual BCA measures. There's a little bit of a shift in the strategy of BCA, which has sort of given us this opportunity as well. And also the science behind the fire growth, which has also changed in the last 20 years significantly, where we're forced to rethink about how we protect these spaces. So the first of those social issues, population density, essentially we've got this huge shift from standalone suburban homes, if you like, to Class 1A homes, to the Class 2 buildings, which are the apartment buildings in that low and mid-rise. And that's a shift from roughly 2/3 now in standalone homes dropping to 1/3, and it's becoming more the majority that are in the Class 2 homes or apartment buildings. So that's really challenging the way that we have to fight fires in these multi-storey residential occupancies. The other one is the BCA. So there is this shift now towards the minimum necessary aspect of the BCA, where the Australian Building Codes Board is saying that, yep, we've got to build these systems to this minimum level. And if you want to go beyond that, you're welcome to do that, but you have to meet this minimum level. So it's not about building the gold-plated sprinkler system for all occupancies. It's got to be fit for purpose. So obviously that's about cost, and this is something that a lot of people in our industry always think is a secondary issue, and I guess it is the secondary issue, but it's a close second, right behind number one, because ultimately, if you don't make these systems cost effective, you will not get change in the industry, which we've come to know now thoroughly. And the trigger point, that 25-metre effective height there, which is usually around about 8 levels above ground, is triggered because of the fire brigade appliances with the ladders. That is the max, that's the extent of their reach. So beyond that is where we start to require a great deal more fire protection. So in that region, you know, below 25 metres or 8 floors, there are some relaxations to be had, and that's the space that we're playing in. To the BCA, so the point that I made earlier about the fire behaviour change is largely due to the amount of synthetic materials that are now filling our homes, and these are extremely hazardous because, of course, they burn, but also because of the toxic gases that outgas in the fire. So that hazard has changed a lot, and as such, it means that we may not be installing these systems to the degree necessary as is required by EP 1.4, mostly because of the fire hazard or change in fire hazard. Now, I'm not, oh, okay. I'll attempt to play this. I was going to play this as an independent video, but let's just see if we can get this. Sorry, folks. So I'm assuming you can see this demonstration here. This is a video that is a test burn, and this demonstrates the point really well. So the room on the left is what we call the legacy room. So you can consider that a room straight out of 1950s, if you like, with natural fibre furniture and, you know, solid timbers and whatnot, as opposed to the room on the right, which is a full of synthetics, and it's a typical modern type of room that would be used in these building types that we're protecting. Now, you can see the clock's ticking down the bottom there, and the room, there is the equivalent fire that's just been started on the same piece of furniture in the couch, and we won't watch this all the way through, but this does illustrate the point really well, whereby you'll soon see, and I apologise, okay, great. Let me just fast forward a little bit here. So we're a minute into this fire, and you can already see there's some thicker, dark smoke on the right-hand side, and the natural fibres there on the left. You can see that there's just not a lot of dark or toxic fumes coming out there. So coming up to, fast forward this a bit further. Sorry guys, I can't see the mount. There we go. Let's just get this at 2 minutes. And you can see that the compartment there is, you know, if there wasn't an opening here, we would have filled the room fully with black smoke. And it's pretty much accepted that if you were still in the room at this point, you're probably not coming out alive. Now, you have to keep in mind that brigades, expected arrival times, it's very unlikely, excuse me, that brigades would be arriving in this kind of time frame. So if this is an SOU up on level 5, a single occupancy unit up on level 5, you know, you're not in good shape if you're in that room. Whereas the room on the left, it's still, you know, we'll put it this way, I'd rather be in that room for sure on the left. So I'll just move this along to about 3.5 minutes, where it really gets into total involvement and complete flashover. So there's absolutely no chance at this point that anybody's going to be leaving that SOU. So okay, I think that really illustrates the point. I'll point you to a link to this towards the end of the presentation, and you can see this video in its entirety for yourself. Sorry, I have to try and get to the next slide. Okay, good. So this is just a visual graphic representation of what we just saw there. This line across the bottom here is the fire brigade expected arrival times. And the red line, of course, is what the fire would do if there were no sprinklers. And this is the green line demonstrating what would happen from a tenability point of view when there are sprinklers. I'm probably preaching to the choir here, but I'm not entirely sure who is watching this. So it's just important point to make that once the sprinklers activate early in a fire, we can control that fire, and we can manage to achieve the objective here, which is not to protect the building, it's to get the occupants out of the building. So it's worthwhile just taking you back to where this all started, and it's a bit of a sad story. Unfortunately, back in the 6th of September 2012, we had a tragic fire at Bankstown in Sydney, where 2 girls were up on the 5th level, and you can see the smoke around this window here, and they were forced to step out onto the ledge to try and escape the fire that had started. And of course, there was no way that they were going to get back in, so their only option was to jump. And unfortunately, Connie Zhang died, and Ginger was left with life-changing injuries as a result of that. So the coroner investigated this and determined that we needed to address this, and the result was essentially that we had to install fit-for-purpose sprinkler systems in Class 2 and 3 buildings. So this was probably a good result out of a really bad situation there, where it gave us the opportunity to see if we could reevaluate how we could build these sprinkler systems and still make them cost-effective yet fit for purpose. So that involved a whole lot of research with the CSIRO, where we effectively built that apartment building up on level 5, but down in controlled conditions, and ran a whole bunch of tests to see if we could establish where some cost savings could be made, but still end up with a safe system. This you'll get a link to, as I said, you'll get a link to a lot of the test results, where you can sift through this data and you'll see that it's quite favourable there. It's important to make the point here that the primary objective of these residential sprinkler systems is not really, I suppose, the original objective of most sprinkler systems back in the day, which was to protect assets and protect the property so businesses could not be too badly affected in a fire. The primary objective here is purely to get occupants out of the building in those early couple of minutes when the fire starts. If we achieve that objective, job done. The system's done what was expected to do. Obviously, with the brigade arriving later, they may deal with the result of whatever is left if the fire is not extinguished or fully under control. The second objective is cost effective. It still comes back to that cost, because if we don't get the cost effectiveness, forget about the primary objective, we're not going to get sprinkler protection in there at all. Through the process and considering costs, we had 2 sprinkler systems, as I said earlier, the 101D system and the 101H system, and you can see how they compare to the existing 2118 suite of systems. This line here represents the cost neutral point. In other words, if you can stay under that line, if you can build a system that's going to be below that line in cost, there's a good chance you'll get it in the code. 101D did that, 101H didn't, and you'll see why a little bit later. But when you consider the both of them in the proposal for change, they pretty well balanced out, and we ended up with a very close to cost neutral result, and the ABCB thankfully decided to go ahead and mandate that. One of the unknown factors when it comes to cost, or little known factors, is the routine service and the repair costs. On average, it costs 5 times more than the cost to install a sprinkler system to conduct the ongoing routine service and maintenance on that system for the duration of the lifespan of the building itself. So essentially, if you can lower the routine service costs, it's going to be favourable, and that's what we managed to do with the 101D system. Just want to make the point here that there was never an intention here to reproduce the 2118 suite of standards. This system was not developed to replace the Australian standard AS2118 systems. These are a different system for a different application, and they meet that application and they go no further than that. This diagram represents the trigger, and apologies, I've just noticed there's an error up there. This says for buildings greater than 4 stories, it should say 4 stories or more. In other words, the trigger to mandate, where sprinklers become mandated, is when you have a residential, a class 2 or class 3 building that is 4 stories or more. You now need to have sprinkler protection in that class 2 or class 3 building. You can come back and look at this slide because they will be made available, and you can kind of read all of the details about the differences, but you can see that, you know, in the building on the left here is not above, it's not 4 stories or above, so therefore it doesn't need sprinklers, whereas the ones that the other 3 do. So just looking at the clause now, this is the clause that sort of triggers the requirement. So class 2 or 3 buildings with an effective height of not more than 25 metres and a rise in stories of 4 or more. That's the trigger that tells you you need it. Item C here is telling us that all areas of the building, even if there are areas that have class 5, 6, 7, 8 or 9A, they also need to be protected. So a couple of exceptions there, and the first one was for 101D, where if 25% of the building is not a residential occupancy, in other words, it's class 5 to 9, then you can't use a 101D. You have to use the 101H or the 2118 systems. So I'm telling you that there are some limits to how you can apply the 101D system specifically. Anywhere where there's more than 2 stories of non-residential occupancy in the building, you can't use a 101D, or above 25% of the total floor area of the building. Or if there is a section of non-residential above a residential floor, you can't use the 101D. So this is just a couple of visual examples. This building contains slightly more than 2 stories, therefore you can't use 101D. And this one has a non-residential use there up at the top, so therefore you can't use 101D. And this is some other various examples of where you can and can't, where the 25% rule kicks in, but again, you can come back and check these at your leisure. Car parks, no change. So the BCA already requires that a car park with 40 vehicles or more requires an AS2118 Part 1 sprinkler system. That remains unchanged. You can protect a car park using the 101D or the 101H systems, provided there are 39 cars or less. But as soon as you trigger 40 cars, you can't use these systems. This is the actual clause, and it just here to make the point that there are 4 system types you can use to protect these residential occupancies now. And obviously a 2218 Part 1, 2218 Part 4, the 101D and the 101H. Permitted concessions, probably the most significant concession, and in fact where we managed to make this really cost effective, was this increase in the maximum distance of travel from 6 metres up to 12 metres. So given that the building is sprinkler protected now, we can increase that maximum distance of travel from 6 to 12. And that allows us, the big change really is that in some cases allows us to, in a building that would normally require 2 stairs, 5 stairs to exit, we can get away with 1 in some cases, and that is of course a huge cost saving for the construction. Another large concession was the dry hydrant. So dry fire hydrant systems are essentially a stock standard AS2419 system, except that it's not connected to a water supply. It relies on it still has a booster inlet, relies on the fire brigade to get water from the street, plug into the booster and charge that dry hydrant system full of water. Obviously, that means that we can get away with installing all of the tapping and the backflow prevention and the whole water supply, potentially pumps and tanks and everything for a hydrant system. We no longer need those. And also the routine service that's, as I told you, is 5 times more than the cost of installing it. All of that disappears as well. So that dry hydrant concession is significant. Where a building occupant warning system is required, you can't use a 101D system. So one of the things about the 101D system is it does not generate alarms. It has no flow switch or pressure switch. For the same reason, you can't have alarm generating equipment open doors or shut doors or have other functionality. If you needed that functionality for some reason for your building application, you can't use a 101D system because it doesn't have those pressure sensing and flow sensing devices. So let's have a look at the specifications themselves now. And we'll start with the 101H system. So H for hydrant. So essentially this is a hydrant supplied sprinkler system. And this one is connected to a water supply, obviously. It's not a dry hydrant system, it's wet. And if you're familiar with the 2118 Part 6 systems, you can think of the 101H system very much as equivalent, except for these main 2 factors. There's a few minor ones as well, but these are the main 2. The water supply capacity has a concession, which we'll talk about in a second, and there are no control valves on every floor. So this sprinkler system connection point here that feeds the sprinkler system on the floor, there is no control valve there on each floor as we go up. It's one system in a similar way that a 2118 Part 1 system would protect this building. It also wouldn't have control valves on every floor or wouldn't be required to have them. So some of the key features for the 101H extends from the hydrant system, very similar to 2118 Part 6. It is the sprinkler part of the building is essentially entirely based on 2118 Part 1. It relies on those clauses. And the hydrant system falls back to 2419 Part 1. So you can always think of this as 2 separate systems, 2218, 2419 combined together in the same way as a Part 6 building typically is. No isolation valves per floor. It requires we'll talk about that in the next slide. I think we'll just try and get through this. Where you require a pump set, you can get away with installing the alarm initiating devices, test drains, main stop valves and whatnot at the pump set. You can see with those arrows there where they are, where they typically would be installed on the pump set. So should be pretty familiar. Where there isn't a pump set, you can connect them down at the booster inlet. So sorry, well in this case it's a H-pattern booster assembly. You can have a flow switch installed, your test drains, even an annubar, a flow testing equipment installed. All of this booster assembly and this illustration here is included in the 101H system and sort of provides some guidance of how to do that. This talks about the flow requirements for the 101H system. So the beauty about this 101H system is, let's take the case where 2 hydrants are required. The top line is telling you when you're figuring out how much water you need, you go to 2419, you find out how many hydrants your building's going to need. Typically, a lot of these buildings are going to need 2 hydrants. So let's take this column as the example. And it tells us that for the sprinkler system, we can have 1 hydrant outlet worth, in other words, 10 litres a second, used to supply our sprinkler system. So that's a concession. So we still build our water supply for only 2 hydrant outlets running, 20 litres a second, and we use our sprinkler demand from that 20 litres a second. It's not included above. It's not in addition to. And the same applies if you need 3 hydrants, then you can still have 1 hydrant outlet supplying the sprinklers. Okay, so the residential areas, or the SOUs, is as per the specification 101H, and the non-residential areas just fall straight back to 2018 Part 1. So a lot of these buildings you're probably familiar with. Your typical apartment buildings will often have a car park down the bottom, or an office space somewhere, or a retail area, or a little shop, or a whole floor of shops, if you like. They are to be protected in accordance with 2018 Part 1. Except, of course, for the water supply, which is the concession. You still get the same amount of water, but it's part of the hydrant flow rate. Piping and supports also falls back to 2018 Part 1 with a couple of changes. Plastic pipes and fittings shall not be used. So we're talking specifically, I think, CPVC pipe is not allowed to be used currently on the 101H system. And that's primarily because of the concern that if you had a large diameter CPVC pipe that was connected to the 101H system, and that large diameter pipe failed in a full rupture, say it was a 50mm pipe, there was the concern that you would lose your sprinkler system as well as your hydrant system, and you would have no more protection, no water-based fire protection potentially. You wouldn't be able to boost it up and maintain pressure. So that was the rationale for why CPVC pipe was not allowed to be used. We are looking to revise this specification, both specifications actually, and this will come up on the table again, and maybe we can give that some consideration. Same for galvanised pipes and fittings, which are typically required on a hydrant system. This being combined, the sprinkler system parts are not required to be galvanised. Balcony protection remains unchanged. It's in accordance with whatever 2018 Part 1 says. Test drains can be reduced from 15mm drains to 10mm. And this is because these are residential applications. That's the worst case scenario from a testing point of view. And we want to make sure that, any alarm initiating devices operate in 90 seconds, not 180 seconds, and that they operate from an orifice that would be similar to a residential sprinkler, which is smaller than for a commercial sprinkler typically. So it's a smaller K factor, and that's where we use the DN10, the 10mm test drain, not the big kahuna, the 15mm, which is going to flow the equivalent of 2, maybe even more sprinklers. So that's not really a fair test. Pumps also are required to start within 90 seconds in this spec. Another thing we've included here is to hydraulically connect our drains. So we know it's been a big problem just to have a drain running inside of a larger pipe, and when you do your flow test, it backs up and causes all sorts of problems. We now want these hydraulically connected so that we can make sure that we're achieving our flow rates and test them routinely without any grief or less grief. This is an example of that sort of connection. The one on the left is a full hydraulic connection. The one on the right is what we commonly see always. And if you do these tests, you know that it's not ideal to have that situation. Commissioning is exactly the same as required for the sprinkler and hydrant parts of the system as per 2419 and 2018. Hydrostatic test for up to 1700 kPa to be held for 2 hours, and a full pump test, pump load test, and a remote hydrant flow test as well. We do make the point that because these systems are combined, it is important that the same person conducts the commissioning of the system. We're worried that we might have, for example, the plumbers doing the commissioning on the hydrants and the sprinkler companies doing the sprinklers, and no one really communicates, and we might not achieve the right demands. Routine service, as I said, big cost there, but it is a requirement because these systems have all the bells and whistles. So that is required as per the standard that talks about these systems, AS 1851. You have to do the monthly, 6 monthly, yearly, 5 yearly, and so on. So moving over to the 101D system, D for drinking, not domestic. It's actually the drinking water. We specify that it, excuse me, it shall be off the drinking water supply rather than domestic. And the reason for that is it could be some of the reclaimed water or recycled water, and we don't want that. It's got to come from the drinking supply. So the schematic really is showing us that this is showing 2 floors, for example, and we'll look closely at the details, but you'll see also that there's an independent dry fire hydrant, which is that concession that we spoke about, and it's not connected to a water supply. And by the way, that's a concession, but it's not a requirement. So if somebody wants to use a wet hydrant system to protect a 101D system, go ahead. There's no issue there. This is just a concession that allows a dry hydrant. Back at the very start, when I showed you the test that we did at CSIRO, we actually tested the system that's on the screen at the moment. This is different to the previous schematic, whereby you can see that there's the domestic plumbing service is tapped straight into the sprinkler system protecting the SOU. So these are taps, drinking water taps and showers and washing machines connected to the sprinkler system. That's how we tested it originally. And that was flowing through the SOU water meter. And the problem we had was essentially that, unfortunately, the water authorities weren't really on board at the time, and they didn't want to give us a larger diameter water meter so that we could achieve the necessary pressures and flows of this system. So we had to scrap this design, and we went to the previous schematic where, as you can see, the water supply is connected directly upstream of all of the water meters, directly into the riser, and is not being supplied by the drinking water meters. This is a schematic. If you haven't had much to do with the system yet, this is a good one because it really sort of demonstrates the whole concept of the system and what's connected to what in a really simple manner. On the left-hand side, the green section is the single occupancy unit, the SOU, and the right-hand side is all of the areas outside the SOU. You can see that the WC there is the toilet. You can see the toilet is fed from the sprinkler system. This is a new concept to the NCC. And there are there's your water meter, obviously, which still picks up all of your plumbing fixtures, but there are two separate feeds that feed the SOU and the outside of the SOU, all of the sprinklers, from an independent supply with its own backflow connection. Key factors for the 101D is it extends from the drinking water supply. You can use PEX pipe. If you're not familiar with PEX pipe is the most common form of pipework used on residential occupancy, certainly Class 1 homes. Copper is pretty rare these days, but still you're welcome to use copper pipe in this system as well. But this is pretty new now that we've got PEX pipe in these types of buildings. The 101D system has significantly less infrastructure than the 2-to-1-8 systems. Obviously, it has no pumps, tanks, and dedicated tapping and all that sort of stuff. No routine service test requirements. There is a requirement to do a survey, just a general inspection, but there is nothing to test. The residential sprinklers are required in Class 2 and 3 parts, so I'm sure Doug will talk to that a little bit later, but we can't be using commercial sprinklers in the SOUs. They must be residential and watermarked residential sprinklers. And watermarked residential sprinklers. Other classes are to be, the sprinklers are to be installed in accordance with the requirements of 2-to-1-8, so certainly quick response and for the hazard. Sprinkler system connects to the toilet, which you explained. We'll get into detail a bit in a second. There is a significant, I think it's a significant increase in reliability of the fact that we're now using the drinking water to supply our sprinkler system. It's an advantage from a reliability point of view because if that drinking water, for whatever reason, is switched off or reduced, we're going to know about it. And we're going to know quickly, and we're going to have to repair it quickly. It's not something that's just going to sit there and, when we get around to it, because it's on its own separate supply, so it's not really going to affect anything else. We will know about it. And also, so faster rectifications of any problems will need to be addressed quickly. just sort of pushing through this. There's a lot of stuff that will be covered in other slides, but you can certainly come back to it at your leisure. This talks about the required numbers of sprinklers to operate. So in the class 2s and 3s and 4s, the residential parts, we need 2 sprinklers operating, each at 66 litres per minute. That extra little bit beyond 2.18 part 5, which is only 50 litres a minute, is to really make up for all of the domestic use that could be occurring at the time of a fire. The class 5 to 9 areas, so the non-residential areas, are required to have 3 sprinklers operating at 60 litres a minute, and that's kind of taken its lead from 2.18 part 4 that talks about the non-residential areas of a part 4 building. It actually uses that same performance requirement. So if we're 5 people, these pumps probably look pretty foreign to us. We may have seen them around, but these are the pumps now that are going to be driving our 101D systems. These are domestic drinking water pump sets that are installed in these types of buildings. They're really reliable pumps. They're usually installed with 100% redundancy. So there's usually a second pump that's sitting there waiting should the first one fail, or they're both running at 50% capacity. They're variable speed drives, so as soon as you open up taps, they kind of ramp up in pressure, and they always keep that constant pressure, which is typically 500 kPa at the discharge of the pump for a lot of these buildings, regardless of how high it is. They just tend to set them there a lot. So very reliable pumps. And as I said, if the pump blows up or even both pumps blow up, these are domestic drinking pumps now, so they're going to be fixed quickly. This is what a water meter room might look like on a larger building, and there's some 20 or 25 water meters there, but you can see on the left-hand side I've indicated where a feed would tap in and feed all of the sprinklers on that floor, just that one floor. So every floor, every water meter on every floor, water meter cupboard on every floor would look like this. There'd be an individual tapping, the green one there, with the backflow prevention device, and it will be supplying all the sprinklers. The important thing to realise here is there is only one valve upstream of that. If you want to isolate the sprinkler system, you have to isolate that valve there in the bottom left-hand corner of the image. You have to isolate this valve, and that's going to shut off your sprinkler system, but importantly, it's going to shut off all of your drinking water at the same time. So I just want to stress that point. If you have to replace the sprinkler head, you shut this valve off, which will shut off all drinking water to the floor. Now, I know that sounds like an incredible inconvenience, and it is. It's designed to be an inconvenience because it means that we have to work a little bit faster and smarter about how we're going to do these repairs and replacements, and we can't shut water supplies to residential buildings and leave them off overnight or for extended periods of time. So that's the schematic there. That's the valve that I'm talking about. You shut this valve off, all of the system goes down, including your water meters. This is deliberately inconvenient to require the attention. I just need to make the point here that there are 2 forms of what we call monitoring. We're using this term monitoring now, and we've typically called monitoring in fire systems being electronic valve monitors. Now we're using the water itself to monitor the availability of protection. The 2 forms are the first one is the general domestic usage of the water. So in other words, every time you have a shower or open a tap, it tells you that there's water to the floor. You've got water in your floor in your building. The end of line monitoring is the toilets, the sanitary facilities here. So that's at the very end of line. Every toilet in the building needs to be connected to the sprinklers, which means that no matter where you are in the building, if someone were to, for example, cut the line here at the feed down the corridor, or it's a part of a corridor to do renovations, no toilets would work in that area downstream. So it's kind of monitoring just at the very ends of the system. So this slide is just talking about the fact that we can use both PEX, plastic PEX pipe, and copper pipe. Also that no PEX pipe is allowed to be exposed, by the way. It all needs to be concealed. Backflow hazard, there was a lot of work done on the water quality of this system, given that it's tapped into the drinking supply. And this is a unique system in terms of its backflow hazard. Nothing compares to it. So we can't really draw any comparisons and say, well, hang on, we do this over here in this system, but 101D does something else, and therefore, you know, we can or can't have this situation. It has to be assessed independently because all of the sprinklers and components downstream of the backflow device shall be watermark approved. So watermark approved means it must be fit for drinking water. It's the same pipe and fittings that you would use for your drinking service in your home. AS 3500 already tells us that when you do that, this is a low hazard environment when you protect it with a dual check valve. So there's two check valves in the one housing there. And again, another thing that's quite different is the fact that the toilets are connected. So that means even in the dead ends of the system, all the way out throughout the building, the toilets will continually drain water and therefore introduce fresh water past that backflow device and into the bulk of the system. To reduce the hazard even further, dead legs, which is essentially just a pipe that is terminated at a sprinkler. Any pipe that's connected to a drinking system that goes nowhere is not going to be flushed, which is the case with when you connect a sprinkler at the end of that line, is considered to be a dead leg, and the specification caps the dead legs to a maximum of 3 meters. That reduces the total volume of dead water in the system in the event that there was some sort of failure with a backflow device or some siphonage or anything else occurred. And keep in mind that dead water is trapped in watermark pipe and fittings, not steel pipe and fittings. But just a schematic here. So typically sprinklers are fitted in the way that A demonstrates here with these dead legs, whereas a flow-through design, demonstrates that you can have this pipe flowing all the way through there and there's no dead ends. A requirement for 101D is that pipes well, the big issue here is once the construction is complete, if for whatever reason we need to remove a sprinkler, we need to be able to do that from below the ceiling. We don't want to be cutting holes in the ceiling to hold against and put a Stilson's or a spanner up there and hold against so that we can unscrew the sprinkler. The fixing must be that we can unscrew it from below the ceiling. This system is to be commissioned in accordance with AS 3500 and also AS 2018 Part 5, which is the domestic standard, and that really relates to the fire components. But really, in all honesty, it's going to be commissioned as an AS 3500 system, which means that we flush the entire system after it's constructed. We conduct a hydrostatic test to 1500 kPa for a minimum of 30 minutes. And we do a water supply proving test to the 101D specification and a full system inspection. Other than that, for 1851, which is the routine service requirements, all that's required is the yearly system inspection. So when they're going around doing their usual inspection of the fire alarms and all other detection and fire protection components, they'll also just check the sprinklers are there and there's no major obstructions or any problems like that. So very briefly here about the dry hydrant system. So as I said, it is not connected to a water supply. It requires the fire brigade to come in and connect here at the booster at the bottom. And this is essentially a dry pipe that runs up the building, usually in the fire isolated stair that will service all of the fire hydrants. That dry hydrant system has been around for a very long time in the NFPA 14 standard in America. You can see that the manual dry standpipe, which is what they call a hydrant over there, and also in the British standards, they use dry hydrants as well and have done for many, many decades. FPA Australia is preparing to provide training and accreditation for upskilling essentially of plumbers. So plumbers are going to be doing a lot of this install work. We expect that. We do know that there's a concern that the plumbers are not entirely across many aspects of sprinkler systems, and they need to be, and it's a genuine concern, and we need to train these people, we need to get them over the line, and we need to have an accreditation system that supports that. Licensing models in all states see this very differently, unfortunately, and we hope to get some alignment once we get an accreditation scheme looking at this. But just be aware that plumbers have all the skills and knowledge to install the pipework. There's no issue there. There's not going to be an issue there. The only issue really is in around trying to upskill them a little bit more about spacing and location of sprinklers, which is a knowledge component. It's not a skill component, it's knowledge. It's something that we can teach via training and bookwork and get them accredited to the equivalents of the sprinkler fitters out there doing similar work in and around the 101D scope of work, of course, and not beyond that. So that's pretty well it, but just sort of harking back to this this original fire, if we think now that when that fire occurred, there was a hydrant system, a 100mm hydrant system in the building, and a domestic drinking water system in that very SOU that had the ability to provide enough protection to prevent that incident. That was always available and never required, and now it is. So I think we've done pretty well here to get to where we've got to. Lastly, I just want to draw your attention to the Home Fire Sprinkler Coalition, which is an initiative between AFAC, which is all fire brigades essentially in Australia, and FPA Australia. This is sort of a joint initiative that advocates for the protection of, for the sprinkler protection in residential occupancies, and that's all occupancies, not specifically for these class 2s and 3s, but also for class 1s as well. So I think that's it there, Doug, if you're still there.
We are still here, Shay. Thank you very much for that. That was really interesting. I think that's the first time I've sort of seen that as well. So thank you for that. I've learned something as well. So thank you. What I will do, let me see if I can't. Sorry, we've been a little bit ad hoc here today. I'm sorry. So let me see if I can't share my screen with you over the Zoom call, and then at least you know what I'm saying as well. And then, if you don't mind hanging around for another
Sure.
15 minutes or so, I will get I'll be able to shoot some questions at you as well that we gather from the people as well. So I will. I can't quite share my screen with you, but I'll continue on with what I'm doing, and let's see how we go here. So my apologies, we had a little bit of a technical disaster. So my apologies for that, those listening in. So let me flash through. Okay, so what I'm going to do now is I'm going to talk a little bit about the Tyco sprinkler range, and I'll put this up now, and what we've got available from what Shay has shown you, and how that fits in with the 101D and 101H systems. So firstly, we do have watermark certification on our entire residential range. So whether that be pendants, sidewalls, flush concealed, we do have a watermark on all of those items. And then we also have a watermark on our standard K8, where you might be using that in a commercial car park or a retail area within a building of this type that we're using. So we do have sprinklers for that. and pretty much every area that you might imagine, we've got a sprinkler that suits that. So we're well covered there, which is great. So in terms of product availability, it will be our standard residential sprinkler that is watermarked, and so we'll be carrying stock of that, whether it be for a domestic system or whether it be for a full-blown high-rise. It's the same sprinkler, so we'll carry stock of all of those. What I'm going to talk about really briefly, because I'm realizing time's getting away from us as it does, is all right, we've talked about low rise. What about high rise, and some design considerations as we think about the high rise systems? So firstly, I'll talk about, in Australian standards, we're talking about AS 2018 Part 1 in 2017. There is a reference to the Part 4 2012 standard as well, but that's really about obstructions only, and I will show you that. The other standard that we use in this area is the New Zealand standard 4541. If New Zealand people are still listening in, I know it's been very Australian today, so my apologies for our Kiwi cousins, but certainly 4541 certainly allows the use of residential sprinklers as well in these light hazard areas. So I've got up there on the screen the AS 2018 Parts 1 2017 and New Zealand 4541. In terms of the coverage areas that we're talking about, you can see that they're very similar. 17 square meters for a sidewall, 21 square meters for standard coverage upright or pendant sprinklers, and where we do differ is that the Australian standard gives us a number which is 37.2 square meters for both extended coverage light hazard and residential sprinklers, which is based on the manufacturer's information of 6.1 by 6.1 square meters. In New Zealand, they do it slightly differently, so there is a reference to the manufacturer's listing, which is typically 6.1 by 6.1. So it says the same thing in a different way. When we come to the maximum spacing for residential sprinklers, you'll see that there on the screen. Section 9.4.4 in the Australian standard. It does reference manufacturer's data, but only to say that if the sprinkler you have is only listed to 5.5 meters, then you're only allowed to use it to 5.5 meters, not to the full 6.1 that's in the standard. New Zealand standards are actually a little bit more pragmatic here, I think. Actually are perhaps a bit more sensible, dare I say, and say, look, if a manufacturer's tested it to 7.2, then do it, because that's in the listing. Not that I'm aware that anyone has tested to 7.2, but typically the maximum is going to be 6.1 meters. Now, something really exciting has happened over the last few weeks, last few days, in fact, which is that we have had an amendment to the standard. How exciting is that? And so I'm if you haven't already done it, go straight to, after this presentation, go straight to Australian Standards webpage, and you can download for free the amendment to AS 2018 Part 1, which actually helps us in a lot of ways. Unfortunately, it's not referenced by the BCA because it was Amendment 1 that made that. But what this amendment will do for us is provide clarification of a lot of the questions that are asked of us and sort of tie up in a knot and answer those questions. So this was literally issued on Friday, was on the website there on Friday on the 17th of July. this is as fresh as it gets, so I'm very excited about this. So steering standard, the 9.4.1 clause changes. Now this has been a little bit of controversy here, because what 9.4.1 says is that it says for standard coverage sprinklers, they must have a K factor of 8.0, which is our standard commercial sort of sprinkler. And what has happened is a number of people have said, well, if you're going to be using these in a residential application, you can't use residential sprinklers because they have a K factor of 7. That was never the intent of this clause. And so you see on the right hand side there that has been amended so that they do have a K factor of 8 where standard sprinklers are used. And we've added a paragraph there that says they are to be installed in a manner to maintain the quick response rating where extended coverage or residential sprinklers are used. So the idea here is the idea was never to remove the ability of the use of residential sprinklers. It was never the intent. It's the way it's been interpreted. So that allows us to use standard listed residential sprinklers in the first place there. The second big thing there is that any reference to fast response, part B, there has been changed to quick response. So that tidies up a bit of that confusion there. If you have consultants that are concerned, or we have fire engineers that are concerned about the use of flush sprinklers, for example, we can use them in accordance with this standard and this clause. It was never really meant to exclude the use of them, just the wording wasn't quite right there. So that's been changed to quick response, which is nice. And like I said, we've included the residential sprinklers specifically as being allowed. It's really important, while this is not referenced in the BCA, it's really important that this was always the intent. This isn't a change of intent from the old standard. It was always the intent by those writing this standard. One of the other changes is that this is clause 9.4.5 in the existing 2018 part 1, and you'll see there that what it says is it references residential sprinklers, but they shall be used in accordance with the requirements of 2018 part 4 and shall only be used as part of a wet pipe sprinkler, and so on. And then it talks about obstructions to water distribution in 9.4.5.1. The intent here was that what we would have is that you would basically, if you have a floor which is residential, you design that floor to 2018 part 4 for the obstructions really only. That was the intent. Unfortunately, 2018 part 4 sort of limits the size or the spacing of the sprinklers to around about 4.9 meters. And so what a lot of people have done is gone, well, even though your residential sprinkler is listed to 6.1, we're going to limit it to 4.9 because of what part 4 says. So there's been a change here. And basically, unfortunately, they haven't reprinted the whole clause, but they said you shall delete these bits and you will add in a heading and so on. So what that does is it removes the reference to AS 2018 part 4 as the design. So we're not designing to 2018 part 4 anymore. The only part of 2018 part 4 which is really referred to in this standard now will be the obstructions. So what we're saying is that the standard design as per 2018 part 1 with using the manufacturer's instructions up to the 6.8 sort of spacing with the obstructions in mind from 2018 part Okay, so hopefully that will clarify a lot of the questions that have gone around there. In addition, there is a new clause in regards to residential. So there's now a clause about incidental residential storage for class 2 or 3 buildings. And what this does is what's happened up until now, I think it's probably largely about car parks, perhaps, where we've got an area in the back of a parking space that is used purely for storage. But you can see there that we can have storage now up to 100 anything up to 100 square meters. Now you're going to have to go to an OH2 or an OH3 in that space. I haven't quite figured out how this works yet, but this is where it is. But basically it allows for a little bit more storage to be added in without having to go to a high hazard classification. We can use OH2 or OH3 classification as needs be. Okay. And that's the exciting news with the new standard. The other thing I want to point out is a discussion I often have about manufacturers' data, and I think a lot of people misinterpret or don't read fully what's in the manufacturer's data and get it wrong, and it's a problem. So take care with the manufacturer's data. Bear in mind that our biggest market in the world is the US residential domestic housing market. That is our biggest market. And so for that reason, the data sheets are actually written around the housing market, sort of up to 4 stories market. That's what it's targeted at. And for that reason, the manufacturer's data is based on NFPA 13R and NFPA 13D, which is actually sort of similar to our new 101D and 101H, sort of, okay, in that the density is 0.05 gallons per square foot, which works out at around 2 millimeters per minute in our numbers. So that's what the data in the data sheet is aimed at. So what a lot of people will do is they say, right, I've got an area 6.1 by 6.1. That's 37.2 square meters. My flow from my data sheet is 75.7 liters at 115 kilopascals, which gives me a density of 2.03 millimeters per minute. Unfortunately, this is not the way we should be designing systems. You'll see down here at point 3 within the data sheet, I might really highlight this because it's really important. So here we have this clause here right under the table, part 3 for NFPA 13 residential applications. So this isn't part R or D, this is 13 high-rise residential applications. The greater 0.1 gallons per minute per square foot, or 4 millimeters per minute, over the design area or the flow in accordance with this criteria must be used. What does that mean? What that means is that 2 Australian standards, we need to, and also New Zealand standards, we need to allow 4.1 millimeters per minute per square meter over that 37.2 square meters. If I work out the pressure requirement for that, it's not 115 kilopascals, it's 475 kilopascals. So what a lot of people are doing is allowing for 115. We'll allow a little bit more, get 150 kilopascals, and that's how they're doing their design, to a very low pressure. But actually you need a lot more pressure. You need 3 times that because the pressure is under a square root, right? So it makes it even worse. So when you're designing and using the manufacturer's data, please be careful that you treat it correctly and design at the Australian standard 4.1 millimeters per minute, and that will give you a much higher pressure. Now we're talking about very high buildings, 60 stories, 40 stories high, and that pressure is probably not a problem because the buildings are so high. But we need to make sure that we consider these numbers as we design these systems. So in summary, I want to thank Shay for his time. We're looking at changes. Thank you for looking at those changes in the NCC, Shay, and that's been a really good thing for us. I hope. I hope that certainly has helped people. Changes to 2018 Part 1. 2017 with that amendment 2. Look out for that. Please download it, get that go and have a look at that. And then the manufacturer's data, please be very careful with that. All right, so Shay, I've got a few questions for you, so yep. You can hear me all right?
You can, yep.
You can, excellent. All right, so we do have a few questions here. You've sparked more questions, I think, than we've had in other weeks, which is fantastic. For residential, this is a great one actually. For a residential building with a car park with more than 40 cars, so I'm going to have a 2018 Part 1 system there in the car park. Yep. Can I use 2018 for the car park and then use FPA 101D system for the residential part?
Yes, you can. There's nothing in the NCC that prevents you from doing that.
Okay, so in that case you're going to be saving on some valves and stuff and so on as well. Okay.
And routine service.
Sorry?
Sorry, and potentially routine service of, flow switches and all the things that would potentially go up that building as well. Yep.
Sure. Okay. Up to 25 meters. So yep. Low rise only. Yeah. Yep. There's a few questions about building occupant warning. Do you want to explain? Are you over how the building occupant warning exceptions work?
I'm actually not, Doug, but I'm happy to. I don't know whether happy to provide contacts back to people on those questions, but I'm not totally across the detection and alarm requirements, to be honest.
No worries. So what we might do with those questions is there's a few of those. We might take them on notice and not apologize. We won't answer them today. But what we will do is we'll have a look at that and perhaps send that on, provide that afterwards in our question and answer sheet. We'll see how we go. What are the watermarked resi sprinklers available from JCI? Well, I've answered that already, so that's good. Question here from NDY. Was there ever a review of using a residential domestic shutoff valve, such as the Grinnell F540, so as domestic water is shut off from the sprinkler system when the system is activated? Was that ever did we ever have a look at that? Was that required?
No, it was never required, and yeah, look, it was considered to a degree, but the reality is the water supply requirements are quite low, 66 litres per minute. It's not a great deal of water, and we're talking about, as it turns out, you need, as buildings grow in size, you need larger water supplies to take care of the domestic feed. So, in all honesty, water supply or flow rates have not really been a concern. But interestingly, when you do have detection systems or even smoke alarms, what's going to happen is people are going to start evacuating the building, which means it's going to free up a lot of capacity. So not only have you got your allowance for the domestic sprinkler system, but you've also got this backup reservoir of unused drinking water capacity from all of those pumps. So I just don't think it's worth the concerns and then the potential testing requirements of including those sorts of valves.
No worries, which is a real shame because I would have loved to have sold some of them. Anyway. Sorry,
put that on the revision. Maybe we could squeeze it in somehow.
That's great. All right. Is there a reason that the systems are permitted, the FPH systems are permitted up to 25 meters in height, but AS 2:1 Part 4 is limited to 4 stories in height?
Yeah, so the 4-story limitation came about when we had a whole bunch of fires in aged care facilities, and it was deemed that Part 4 was suitable for that application. Now we've got the situation where we're putting sprinklers in buildings that were otherwise unprotected. Until this NCC, there were no sprinklers required. Now we've got the sprinkler system that is protecting up to 8 stories, let's say. But like I said at the start, you're also allowed to use the Part 4 and the Part 1 systems in these residential buildings. So I think to answer the question, it's both. You can use a Part 4 up to 8 stories now for Class 2s and Class 3s. But when you're talking about the aged care facilities, we're talking about 4 sprinklers operating there now, not 2 sprinklers operating. It's a different hazard, different application, and that's why that's capped at 4 stories.
Okay. What are the main considerations with retrofitting an old non-sprinkler protected building with a D system?
Okay, the main considerations obviously are going to be cost there. Now, I can tell you that there's been a lot of interest from buildings that have cladding or problematic cladding on them, and the potential for installing or retrofitting these 101D systems into those buildings. So this is a legitimate issue, a legitimate solution now. The issue is only going to be around cost. There's no reason you can't retrofit a system, and in fact these PEX-based systems go in so quickly now that it's becoming, they're by far the cheapest ones to consider a retrofit. But the issue, I think, from the experience that I've had with trying to investigate this as a solution is the aesthetics. You've got to conceal the pipe and it's got to look good, and most of these occupancies have, you know, or each of them have their own limitations on what looks good. So what you don't want to do in a retrofit situation is tear the ceiling down, put a sprinkler system in and then rebuild the ceiling, because it's going to cost a fortune. But if you can install that below the ceiling and use sidewall sprinklers and conceal that pipe, we can get a reasonably cost-effective retrofit solution here. And that's come about because of the cheaper PEX pipe solutions that connectable fittings that they're using to get that pipework installed quickly.
Cool. Okay. Question from Cyril MacGyver in the ACT. I'm sure you know Cyril. Why does the water authorities not worry about using the D system without metering?
Okay, great question. And we've done this many times over. So I just want to clear the issue here. There has been concerns about not metering the water that's going to the toilet. But in fact, at the incoming main from the town main, there is a main water meter that meters all water, which of course includes the toilet water usage for the 101D. So the water is being metered, and the water authorities can essentially charge for the use of that water. What's not metered with this system is the individual use. So for example, if you're in SOU number 7 and you've got a single occupant in there and you've got SOU next door number 8 and there's 6 people living in there, they're going to use more toilet water than you are, and the issue is about not so much the metering but even just the billing of how the fairness about the billing of how you would do that. Water authorities have come to the party. This gives me just a brief opportunity to say that we are reviewing both 101D and 101H, and what is on the table now is the possibility of going back to the original design, which you might remember flows through the drinking water system. It's a flow-through design, no dead legs, and that will mean that all water usage is going to be metered per SOU. So both options could be available, fingers crossed, as we go forward.
Okay, so the main water meter will probably rely on the overall strata paying for the water anyway.
Correct.
Yeah.
Correct, and we're doing that, for example, with when there's swimming pools and other maintenance issues, and certainly even you know, the external taps and watering and irrigation around those buildings. That's all managed by strata and billing, and it's distributed in a similar way. So is sewage, by the way. No one meters sewage water, you know, per SOU, but it's kind of considered holistically and billed as such. So we will apply that. I assume that the strata will apply a similar approach to the toilet water usage.
Yeah. So and of course we're not using it's not the sprinkler system that's going to be using the water, it'll be the toilets. Yeah. So we can expect in the future all of our taps and so on connected to the toilet water, which will be fantastic.
I think so. Yeah.
Another question about occupant warning, we'll come back to that one. Sorry, James. All right, can the D system support external window drenchers for exposure protection?
Yes, it can, provided that sprinkler is watermarked. So I'll hand that one over to you, Doug.
Yeah, no problems there. So that we're sweet there. I think that we would need to make sure also that we're compliant with, obviously, with TUDO 18 Part 1, where we're talking about window drenchers in one of the sections there, and making sure that we're compliant with that. But the K8 sprinkler is available, so that should not be a problem for you there.
To that point, Doug,
yep.
The sprinkler manufacturers, certainly Johnson, have done a fantastic job in stepping up to the big challenge of having all of their sprinklers watermark approved. And it's primarily for the 101D system, but there is another opportunity here. We currently use these window drenchers from domestic suppliers, and they're not watermarked. So I would be suggesting that going forward, now that we've got this capability to provide watermark sprinklers, that anything that's connected to a domestic supply, regardless of backflow prevention, should be using watermark sprinklers.
Okay. Question here, can we have an external dry fire hydrant?
Yes. Yes.
Okay.
Yeah.
Yes.
So the hydrant system is in accordance with 2419, so it can be exactly the same, but it's just got no water in it. Yep. Okay.
No worries. I mean, at the end of the day, the fire hydrants are for fire brigade use only anyway. So you're going to have the appliance there to drive it regardless. Yep. Okay. And I'll take this as the last one, and then we'll wrap up for the day. And I might send you a list of other questions, Shay, and we'll answer them at your leisure. So a Part D or H sprinkler system cannot be used with the Class 7A part other than no 101 system is to be used. I might come back to that. I'll have to come through that question and figure out what it's asking and come back to it. But look, thank you very much, Shay, for your time today. I'm going to put your details up if people need to contact you alongside mine as well, if that's okay. I'm assuming that's okay. So if you need to contact Shay in regards to a general question, please do so. We're as an organization have made sure that we're pretty familiar with these systems too, so please do not hesitate to contact us either. But look, thank you very much for dialing in today, and we will catch up with you next week. Next week we're going to be talking about pumps Now I know we as an organization, as Johnson Control, don't do pumps unless it's a water mist pump. But Greg Graham, we're very fortunate to have Greg Graham in our organization. He's spent many years in the pump industry, and so he's going to be talking about design of pumps, how we make sure that we get that spec right, and so on. We'll make the disclaimer immediately, we don't sell the pump, so we're not responsible, but we'll still be talking about them next week. So thank you for dialing in, and we will catch up with you next week. Thank you very much, Shay.
Thanks, been a pleasure. Thank you. Bye.
Thank you, everyone.